Hello, my dear student. Today, I will discuss question number 11. This question is asking by one of my favorite students. So let's have a look of diagram 6. Shows the curve. So let's underline the curve and circle the important curve and gradient of the tangent to the curve at point P is 6. From this sentence, gradient of tangent, we will convert to the symbol dy dx, which is equivalent to 6 at point P. So the point P was not given. So later we will have to find point P. So the first step is we will read the question and convert the keywords gradient of the tangent to the symbol. Gradient of tangent is dy dx. So let's go to the curve. This is the curve, and let's differentiate the y, which is 2x. And as mentioned earlier, 2x is equal to 6. Hence, we can solve the x, which is equivalent to 3. In order to find the y, we will sub the 3 into the curve, which is 3 squared plus 3. So the answer for the y is 12. Hence, we can say that the point P is at the 3, 12. So at this point is 3, 12. Alright? Now, let's proceed to the next question. Is asking for the area of the shaded region. So in order to find the area of the shaded region, we need to look at this diagram. If we are going to find the area under the curve, this is the curve, we will get the area that I am highlighting using the purple color line. This is the area under the curve, and this is the curve given y equal to x squared plus 3. So let's integrate the area under the curve in purple color from 0 to 3 for y bounded by the x-axis is dx. So here will be y, but y is given by x squared plus 3, right? So then we will integrate x, 3, 2 plus 1 is 3, over 3, integrate 3, we get 3x, and we will sub the limits from 0 to 3. So the area is equal to 27 over 3 plus the 3 times 3 minus the 0. So the area is 9 plus 9, which is equivalent to 18 units square. So, but the shaded region is not inclusive of the triangle here. So for this triangle, the triangle in red color, we need to minus out. So in order to find the x-intercept, we will use the straight line. This is a straight line, which is the tangent. So hence we need to form the equation of tangent. Y equal to mx plus c. Remember, tangent is always y equal to mx plus c. So let's have a point at the 3, 12. The gradient of the tangent was given 6 just now. 6 times the 3 plus c. So 12 is 8 is equal to 18 plus C. So C is negative 6. Alright, C is equivalent to negative 6. So we need to minus out the area of the triangle. So we have the equation 6x minus 6. At this point, the y is equivalent to 0. So 6x equal to 6. Hence, x is equal to 1. So here is 1. So then we will find the height and the base here. The base here is, okay, let's work out the base. 3 minus 1. So we will have 2. So the area of the triangle is 1 over 2, 2 times 12. So it's 12. So hence area of the shaded region is 18 minus 12, which is equivalent to 6 units square. Alright, so we have solved the area under the curve. Then the area minus the triangle, we get the area of the shaded region. So let's highlight again. The purple one is 18. This one is 12. And here is 18. Right? The area in purple color. So hence the balance is 18 minus 12, which is 6. So that means the area shaded in green color is 18 minus 12, which is actually equivalent to 6 units square. Now let's start with finding the volume. The volume of revolution in terms of pi when the region bounded by the curve. Okay, let's highlight bounded by the curve. We need to find the region first before we can find the volume. Straight line y equal to 12 and the y-axis is revolved through 360 degrees about y-axis. So in order to find the volume in terms of pi, we need to highlight the region, the area. The curve is the boundary, the straight line is another boundary or borderline, and y-axis. So let's go to the diagram and see where is the region. The curve, straight line y equal to 12 and y-axis. Okay, so let's erase the curve, which is here. This is 312. So y equal to 12 will be here. This is 12 because the coordinate here is 12. And the y-axis, see or not? You need to highlight the area or the region. For this area shaded in red color, if we are going to rotate about the y-axis, what will be the volume looks like? Okay, let's try to sketch out, right? So the volume that we expect to get if we rotate 360 about the y-axis, we will get the shape something like this. Right. So in this case, we will have to use integration pi, volume equal to pi integrate, because the borderline here, the boundary is y-axis, so it's dy, and here will be x squared. Right, so the x squared is equivalent to y minus 3 equal to x squared. So we substitute volume is pi integrate y minus 3 dy and the limit will be from, look at the curve, is if x is 0, the y here will be 3 to 12. So we have to identify the lower limit and upper limit from 3 to 12. So let's integrate to find the volume. It's y squared over 2 minus 3y from 3 to 12. So let's substitute carefully to get the volume in terms of pi. So we have 12 squared over 2 minus 3 times 12, and then let's put a bracket, and we are going to minus out the 3 squared over 2 minus 3 times 3, and then we close the bracket. Now we need to simplify. So volume is equal to pi 144, which is 72, minus 3 times 12, which is 36, minus 9 over 2, minus 3 times 3, which is 9. Because this is minus, so here be plus. So hence the answer that we get will be volume is equal to 36 plus 9 over 2. So the answer is 40.5 pi. This is 4.5, right? 4.5 plus 36. So this is the volume generated if the region in red color, which is this one, region in red color, is going to rotate about the y-axis. So in order to find the volume, we need to identify the area of the shaded region, right? So that we can work out the lower limit and upper limit, and also the shape by itself looks like this. This is a 3-dimension volume generated when the curve is going to rotate about the y-axis. Alright, so that's all my sharing for today. Till then, bye bye and have a nice day.